to say that. Our group is cooperated with NET as a group. In the moment, we cannot say NET. We should say Professor Watermas.
Next is okay.
Okay. I think everyone introduce itself. Ned, could you start from you first?
Okay. Hello everyone. My name is Wantama Jantasin. Normally, EBN group call me Ned. Actually, I'm a NPUST alumni from 2007. Okay, and today is only me and my student. One student, she is a PhD student, will join this seminar.
Okay.
Very glad to join this seminar again. Okay.
Okay. Okay. Next one, Chet.
Good evening, everyone. My name is Chet. I'm undergraduate fourth year student, and I'm from Nepal. And now I'm doing research on poultry. Yeah. That's my introduction.
How to call your situation? Is you are undergraduate, but you already joined a postgraduate course.
Oh, yes, I'm also doing the pre-master course. So I'm having some master's courses as well.
Okay. Next one, Nurita.
Good evening, everybody. Maybe Ned still remember me.
Yes,
okay,
yes.
I come from I come from Indonesia, and I also the alumni for the master degree. I'm sorry, I forget the year. Maybe around 2000. I finished my study master is 2013. Okay, thank you.
Later, you need to be a little bit large voice, okay? Because I cannot hear. The voice is too low. Okay, next one.
Okay.
The Thai student. Yes.
Hello, everyone.
Mm-hmm.
My name is Kanika Hampakon. Actually, call me Me. Yes.
Me.
Me. Yes, me.
Oh.
And I'm a PhD student. Yes. And Professor Dr. Net Ajanet is my co-advisee. Yes. Nice to meet you.
Okay. More than welcome. Your accent just like a net.
Like a Thai accent.
Yes, right. Next one, Sue.
Good evening, everyone. I'm Sue. I am the NPUST PhD student, but also assistant for Dr. Hsia. And my major is for pig, but I also know a little bit about dog, chicken, and the other animals. Okay. Thank you.
Mm-hmm. Sujin.
Hi everyone, my name is Su Jun. I graduated Donghai University for 2 years. Then I worked on pig farm for almost 2 years. Then I joined Dr. Professor Hsia's group in this month. 好。
Okay. Yes. Next one. Thank you. Next one, she's a new member. Okay. Next one, Eswa. Eswa, please.
Yes. Good evening, everyone, and also Professor. So, my name just called me Aswa. I'm a first year for the PhD student of the Dr. Hsia, and right now I'm doing research related with the acetic anthropenic acid in the code. So this is the first introduction for me. Thank you, and back to the Dr. Hsia again.
He's also alumni of our university. He was a Professor Zhang Xiuruan's student. Zhang is retired just a few months ago. 还没啊，真的啊？Oh, sorry. She is not retired yet. So I still need to be very careful about talking to bad words about Zhang. So Eswa we're not talking to her. That's just a joke. Okay, next one. Wei Jun.
Hello everyone, and
大声一点，听不清楚。
hello everyone, my name is Zheng Weijun, and you can just call me Jason, and I'm the NPUST Animal Science student, and I'm a freshman, and I joined this group since like 4 months, and I quite not remember the date. And hello everyone.
OK， 李小姐介绍你自己。
Okay, everyone, good evening. I'm Li, and I'm assistant to Professor Hsia for almost 30 years. And now is also my last years of study in PhD program. I hope I can graduate soon. Okay, thank you. That's all.
Everyone is which you can pass this year. Otherwise, okay. No more other student. Okay. The last one is myself. My name is Hsia. Hsia is mean summer. Everyone called me Hsia Liang Zhou. Hsia Liang Zhou. If upside down, you can call me 揍两下 Okay. 揍两下 is mean hit you twice. I'm interested in all kind of animals, including the human being. Okay. So that is my interesting. This seminar is actually started from quite early. You can say the seminar origin is started from the Pig Research Institute. That is about 50 years ago. And when we started the seminar, at that time is every Thursdays afternoon, 2 o'clock. Because in the research institute, so we can fix on the afternoon. But when I moved to NPUST, we have no chance to have this kind of seminar in the daytime, because daytime every student have a course, and another thing is because many students still need to work in the farm, so they have no time to join this seminar. So we have to choose in the evening. And why choose evening at this time is because in Taiwan, the time is 8 o'clock, around 8 o'clock. And 8 o'clock is just everyone finish their farm work, so they can come to join the course. That is why we are holding this seminar at 8 o'clock. Okay. By the way, at the moment, I'm not asking all guests to have any presentation. So please, more than welcome you come. Don't worry about me to force you to give any kind of presentation. Okay, but in the future, please, if you want to give any talk, please join us. Okay, my student will be give a presentation in turn. So everyone have to give their own presentation. During the presentation, sorry says that we have to speak English. There is no choice, because if we speak Chinese, many students cannot understand. And if we speak some other language, I cannot speak. For example, I cannot speak Indonesia or Nepal's language. So maybe the best way is speak English, and then it's also very good for everyone to learn, to practical, not to learn, to practical your English. Okay, and you can use to we speak Chinglish, and I can use to you speak Tigrish. Okay, and I also can use to Nepalish or Indonesianish. Okay, so once you use to all this kind of accent, and then you will be very easy to survive in the international situation. Okay, I'm really glad Ned will agree to have to join us. Okay, thank you, Ned, and also your student. And I hope in the future your students who can join us. Don't frighten them. Don't threaten them. Okay, I'm threatening them in maybe too long. So you also threaten your student. Uh, they will worry to come. Don't let them too worry to come. Okay, today is Nurita's presentation. So Nurita, it's your turn now. Okay, so the rest of us need to switch off the speaker.
Good night, everybody. Excuse me, is my voice is clear? Okay, good night, everybody. Especially for my classmate and another invited guest, and also Dr. Hsia. Today, I would like to present about amino acid and thiamine in high concentrate diet for ruminant. This is a review. Actually, this is for my seminar presentation in 27 May. Okay, this is my outline, and I will follow this outline. And first, I will start from the introduction. Okay, from this figure, this is one of the species example for the ruminant. So ruminant is a very special herbivore because it has a 4 chamber. The first chamber is the rumen, second is reticulum, third one is omasum, and the last is abomasum. And two and the second chamber, rumen and the reticulum, is very special because uh, its chamber contains with bacteria, and the bacteria will help the ruminant to digest or to ferment the feed, and then the product from the feed can be used for the animal to maintain or product mm, to uh, maintain or to uh, for production of meat or milk. And I'm sorry. There are two major categories of feed for ruminant. First one is forage, and the second one is concentrate or contains with grain. And the ruminant lack the enzymes necessary for digestion and fermentation of feed. The rumen microbes are essential for host survival and performance. The rumen microbes break down feeds to produce volatile fatty acids, which are used by the cows as energy for maintenance and production. And this figure, I would like to show or explain about the how from the dietary protein from the feed will be able to produce the microbial protein. The first, this is a dietary protein will be divided into undegradable protein and the degradable protein. The degradable protein will be breakdown into the amino acid and peptides using the protease enzyme. And then both of the amino acid and peptides will be insert uh, into the ruminal bacteria, and both of these source will produce the microbial protein. And next, this is about the amino acid profile or the amino acid composition of the rumen bacteria and protozoa in the cattle. From this figure, I would like to show if the rumen microbes uh, has amino acid inside of their body. And then from this table, I would like to show between the amino acid content from the bacteria and the protozoa. The first one, I give the red square for the amino acid which is higher in the bacteria. In here, we can see the alanine, glycine, proline, and valine has a highest number in the bacteria. And then I give to the blue square for the amino acid content which is higher in the protozoa. As I mentioned, is aspartic acid, glutamic acid, ile ileosin, and lysine. Rumen microbial protein represent a major source of amino acid to the ruminant animal. Microbial protein contributes about two-thirds of the amino acid absorbed by ruminants. Amino acids are building block for protein in our animal. Some amino acids regulate key metabolic pathways that are necessary for maintenance, growth, reproduction, and immunity. Lysine and methionine have been identified most often as the most limiting amino acid in ruminant. And next, I would like to uh, explain about the high concentrate diet. So a high concentrate diet or grain diets promotes the growth, productivity, and quality of meat or milk production in beef and dairy cattle. However, excessive intake of rapidly fermentable carbohydrate in concentrate could induce the occurrence of the subacute ruminal acidosis, or it's we can say it SARA. So this figure uh, is a flow chart about the ruminant acidosis cycle is caused by excessive consumption of fermentable carbohydrate in the rumen. So when the animal get of receive a high concentrates, then the intake of the starch and the fermentable carbohydrate will be higher, and it will increase the production of volatile fatty acid. And then it may affect the pH, so the pH is decreased and the osmolarity in the rumen is increased, and then it's make the pH is below 6. After that, the digestion of fiber will be getting lower. Also, the microbial growth and population is getting lower, and it will continue with the pH going down is become 5.8. And when the pH of the rumen is around or below the 5.8, it's happen the increasing growth of the Streptococcus bovis and the and production rumen bacteria which is produce the lactic acid, and it might cause the death of the protozoa. In this part we call it SARA or subacute ruminal acidosis. If the pH continuously going down below the 5.5, it happen glucose accumulation in the rumen and then increase the dilactate, and also reduction of the bacteria or the death of the bacteria, and then some of the pathogen bacteria will be still able to live and release the endotoxin, and it causes the pH is less than 5, and we call it the acute acidosis. So the SARA is the part between the pH is around 5.5 until 5.8. The next introduction, I would like to explain about the vitamin B, or we can also call thiamine. Thiamine is also known as vitamin B1, is one of the water-soluble B vitamins. Thiamine is ordinarily synthesized in sufficient amount in the rumen by bacteria with adequate forage diet. When ruminant and overfeed high-grain diets or concentrate, the subacute ruminal acidosis or SARA occur and results in thiamine deficiency. So it has correlation when the pH is going down, so the thiamine production also become lower, so it's happened the thiamine deficiency. And next, I'm going to the objective. The first one, I would like to review the effect of the lysine and methionine supplementation on the ruminant performance. And the second one, I would like to review the effect of thiamine supplementation in high concentrated diet on ruminal condition. Next part, I would like to move into the literature review. So this literature review, I would like to describe about the amino acid. So the first table, I would like to explain about the effect of the lysine addition in the feed. It may increase the dry matter intake. So we can see without addition of lysine, the dry matter intake is lower. So we can see both of the phase, the prepartum and the postpartum of the dairy cow. Without the addition of the lysine, the dry matter intake is lower. Comparing with the addition of lysine, is the dry matter intake is getting higher. And another part make me interesting is about the free fatty acid and the beta hydroxybutyrate in the postpartum dairy cows. We can see in this table if the addition of the lysine, it will reduce the free fatty acid and beta hydroxybutyrate. Uh, it can be explained because the free fatty acid uh, is I'm sorry, the oxidation of the free fatty acid can be done with the carnitine, and the precursor of the for the carnitine source is the lysine and methionine. So when we add the lysine and then the carnitine is getting higher, and then the free fatty acid and beta hydroxybutyrate can be oxidized in the cell. In this part is in the mitochondria of the cell. And this is another experiment, but it's before is the amino acid is lysine, but this next one is the methionine. It has a dissimilar result, we can see in the triangle. The white triangle is with the addition of the methionine, but the black triangle is the control one. Both of this prepartum and postpartum phase, we can see if the dry matter intake with the addition of methionine is getting higher comparing with the control one. So we can see if the addition of methionine increase the dry matter intake of the dairy cow. And we go to the next table. In here, I would like to explain about the effect of the methionine for the daily gain. Sorry. So we can see here, without the addition of the methionine, the daily gain is 0.27 and it's getting increased with the addition of the methionines. So it's become 0.38. And next is still the addition of the methionine. In the red square, I would like to mention if the increasing addition of the methionine will affect the nitrogen retention in the growing stir. And for the next literature review, I would like to explain about the thiamine. So in this figure, in this table, it mentioned about the effect of the high concentrated diet feeding with thiamine supplementation on the everyday matter, milk production, ruminal pH, ruminal thiamine content, and the ruminal VFA content. So in here, I would like to show if the addition of the thiamine, so the CON is control, and then the HC is the high concentrate, and the last one, HCT, is the high concentrate with the addition of thiamine. We can see from the middle, the HC, the average region is lowest rate if we compare with both of the treatment. So the dry matter intake for the high concentrated diet is the lowest one, and then it getting slight increase when the addition of the uh, thiamine, and it's also happen for the another measurement. I mean, in here is the ruminal pH, ruminal thiamine, the acetate. It has a positive correlation. So when the addition of the thiamine, it will increase the ruminal pH and then ruminal thiamine and the acetate. But in other hand, when the animal receive the high concentrate diet, the propionate is getting very high. But when it's getting very high comparing with the control. But when we add the thiamine, it's getting lower. So the next table I would like also explain about the similar measurement about the effect of the high grain feeding and thiamine supplementation on rumen fermentation parameter in the dairy cow is similar result from the previous one. We can see if the parameter which is I put in the red square, it has a correlation. So when the animal get a high grain diet, the ruminal pH, thiamine, and acetate is the lowest one. But when the animal get the high grain diet with the addition of thiamine, it's increased increase rather than the high grain treatment. And the similar also happen for for the blue square. I would like to mention if the high grain diet, it's increase the lactate and the propionate comparing with control and the addition of the thiamine. So we know there is a positive correlation between the ruminal pH, thiamine, and acetate, but it has a negative correlation with lactate and propionate. And next, this figure, I would like to explain about the effect of the high concentrate diet for the rumen bacteria population. I give two different color for the two different species of the bacteria. So the red one is Streptococcus bovis, which is it's a lactate producer bacteria. And then the second one is Megaspira elsdenii, which is this one is a lactate consuming bacteria. So we can see from this figure, the white one is when is the control, the black one is the SARA or subacute ruminal acidation, and the last one with the strip is the subacute ruminal acidation with the addition of the thiamine. So we can see from this figure, if the Streptococcus bovis or the lactate producing bacteria is very high in the SARA condition, comparing with the control, but when the addition of the thiamine, the Streptococcus bovis is getting lower. And then I go to the Megaspira elsdenii. We can see from the control, the population of the Megaspira elsdenii is high. And then when the SARA condition happen, the lactate consuming bacteria is getting lower. And then when there is an addition of thiamine, so the population of the Megaspira elsdenii is increase again. So because when the addition of thiamine, it will maintain the rumen condition, the rumen pH is getting higher, so the Megaspira elsdenii can grow again, and it can depress the Streptococcus bovis. And next figure is about thiamine condition, thiamine supplementation. The effect for the ruminal epithelium. The A1 is control and B is the high concentrate ruminal epithelium with the high concentrate diet, and C is a picture of the ruminal epithelium with high concentrate diet and supplementation of thiamine. So I start from B. From B, we can see in the middle there is a pinkish color. So this pinkish color is very short comparing with the control and the high concentrated diet with the thiamine addition. So the pinkish color on inside of this ruminal epithelium is getting shorter or smaller because it's when the SARA occur, and then when the pH is getting down, so the bacteria pathogen which is still able to live, they produce the endotoxin, and then the endotoxin is released the LPS. It's a lipopolysaccharide, which is toxin, and this toxin can uh, reduce the papilla in the the epithelium of the rumen. but with the addition of the thiamine, so when the thiamine is added in the concentrated diet, and then the epithelium is getting larger again, because before I mentioned about the LPS, when the pH is getting increased, and then the pathogen bacteria is reduced, because another good bacteria is growth again. So the population of good bacteria in the rumen is growth again, and the LPS level is down or reduced. And the next one is the effect of the thiamine supplementation for the ruminant epithelium. In this figure, I would like to show if there is a different. We can see from here the control is the highest one in the rumen epithelium. In comparing with the high concentrated diet, it's getting decreased a lot. And when we add the thiamine during the in the high concentrated diet, so the thickness of the epithelium is increased. It's similar happen. I mean, it's similar with the previous picture. So this is my summary. The addition of lysine and methionine in concentrated diet for ruminant may enhance the dry matter intake, nitrogen retention, and daily gain. And the second one, a high concentrated diet with supplementation of thiamine resulting elevating ruminal pH, increasing dry matter intake and acetate concentration, and improving ruminal epithelium. And for the future work, the supplementation of amino acid and thiamine in high concentrated diet is expected to fulfill amino acid requirement and improve rumen condition. This is my reference, and thank you for listening.
Thank you for Nurita's presentation. And anyone have some kind of suggestion, comments, or question? Susu first.
Okay.
Yeah.
Okay. I have some question about can you easy to explain that the mechanism of the thiolane can work? Why the thiolane can work under the high concentration situation? If we just provide like the ratio with the raw hedge, like the 50-50 in the normal situation, so the B1 can be worked or not. Thanks.
Okay, thank you. So, in my understanding, if the ratio is 50 forage and 50 concentrate, I think the ruminant animal still able to produce the thiamine, and then it's still able to maintain the rumen condition, because thiamine is very important, as I understand. If the thiamine is produced by the cellulotic bacteria, so if the forage is enough, and then the production of the thiamine still can be fulfilled for their requirement.
Do you think if you can find some kind of information about why the thiamine can mechanism of the why the thiamine can improve all these kind of things. Why? So maybe the best way is to find out some kind of mechanism. Why? Okay. Otherwise, we cannot easily to explain. Okay. And of course, you also mentioned about the riboflavin. Okay, it's also very important one. Okay. As well.
So dealing with the thiamine itself, the first can you say that the
You need to do nearby your microphone. Yes, right.
In the slide 16, you mentioned that the, can we show the 16?
16, page 16.
This one?
Yes, enlarge review. Yeah. So before you mentioned about the Elsdeni as a bacteria that digest the lactic acid. My question is, this bacteria digest lactic acid is because of we provide the vitamin B, or this bacteria can digest the lactic acid from the Streptococcus is because of the higher pH of the rumen.
I'm sorry, would you please
You mentioned before that the Streptococcus bovis is a type of bacteria that produce lactic acid.
yes.
Then you also mentioned that the blue square is a type of bacteria that digest the lactic acid. Based on this situation, dealing with the thiamine, the Elsdeni bacteria can digest the lactic acid is because of we provide the thiamine, or it's because of the pH of the rumen that getting increased. So which one is the more be the major effect, increasing pH or providing the thiamine itself? I just want to curious about that. Thank you.
Okay, thank you. So I would like to explain again. So when we add thiamine in the high concentrated diet, it will improve the pH. So the pH is getting improved. And then the Megaspira elsdenii can grow well. So it can consume the lactate. But during the condition of the high concentrated diet without any addition of the thiamine, the Streptococcus bovis is growth very well, or its growth high, and then it's produced a high amount of the lactate. So the correlation between the Megaspira elsdenii, actually the first one, the thiamine is increase the pH of the rumen, and then after that the Megaspira elsdenii can grow well, and it help to consume the lactate.
Okay, thank you.
So as well, can you can understand now?
Yes. So I just
Okay.
point out that the thiamine, the first pathway is it will increase the pH, then the activity of the Elsdiani getting higher. So the first
Okay.
is because of increasing pH, then its effect on the Elsdiani, and it will reduce the lactate from bovis, Streptococcus bovis.
Okay. I think everyone needed to notice one thing that is very important. That is vitamin B group always play a very important role on the glycolysis. So once you can play a very important role on the glycolysis, and so you always will produce higher lactic acid, and so your acid situation will be higher. Will be lower. Sorry. Okay, so this is we have to be very serious to consider about this. But on the other hand, if you can produce more bacteria, this kind of bacteria can induce the more lactic acid or uh, acid produce, and then you will become more low pH environment. That is why sometimes this kind of vitamin add into the luminant nutrition still can function well. That is another very key point in this kind of luminant nutrition. 郑伟俊是吧？有没有什么问题？是你讲中文，我讲英文。
I have no question.
Oh, you have no question?
Yes.
Okay. The
maybe because I don't have enough background knowledge.
Okay, it's okay, no problem. Any question from the audience?
Professor, I have one question.
Yes. Oh, shit! I didn't ask you because I cannot see you.
No, it's okay.
No, I need to see beautiful, handsome boy.
I'm also curious about the relation between the thiamine and propionate, but you already explained about that, so I think it's clear now. And Nurita, can you explain more about page 17, that figure? In
17.
Yes, this is very beautiful figure, right? And in this, from A and C has the high concentrate with thiamine, right? And control high concentrate with thiamine.
Yes.
In this case, the A and C looks kind of similar, right?
Yes.
Can you explain more about this one? I didn't get it, sir.
Okay. Okay, I would like to explain again. So I start from the figure B. This is the ruminal epithelium when the goat get high concentrate diet. So inside of the ruminal epithelium is getting shorter because the effect of the, we call it LPS or lipopolysaccharides. It's kind of toxin. When it's absorbed in the ruminal epithelium, it will cause the shorter of the ruminal, the pinkish one, the inside of the ruminal epithelium. So the LPS, which is affect this ruminal epithelium, is produced by the bacteria pathogen when the subacute acidosis is occur. So the bacteria pathogen, which is still able to live in the lower pH, produce high of the LPS. So when the LPS is absorbed in the ruminal epithelium, it will cause the shorter of the inside of the ruminal epithelium comparing with the control and the high good receive high concentrated diet with the supplementation of thiamine. So the correlation with the thiamine, why when the goat get thiamine and then the inside of the ruminal epithelium getting larger again, is related again with the ruminal pH. So when the ruminal pH is getting higher, as I mentioned before, and then the good bacteria also grow well, and then the growth bacteria will depress the bacteria pathogen, which is produce the LPS. And then when the LPS is reduced, and then also it means the absorption LPS in the ruminal epithelium also reduced, and we can see the inside of the ruminal epithelium is getting larger again. That's my answer. Could you understand?
Mm. Is there anything to do with acid? Like usually the high concentrate diet in group B has the higher propionate, right? In
Yes.
group C also the high concentrate diet with thiamine, the
Yes.
propionate will decrease and acetate will increase, right? So is there
Yes.
anything to do with acid, production of acid in this case?
Uh,
No.
Actually, as I understand, in the B figure, actually it's not the concentration of the acid is not propionate in and acetate is higher, but it's is in the B situation is higher in the lactate acid. But for the A and C, it's the propionate and the it's changed again the propionate, but the propionate is lower that and the acetate is getting higher.
Mm.
Is
Okay,
that
thank you.
okay? Thank you.
要不我需要帮忙吗？
Okay, maybe uh, another person want to ask or give me suggestion.
Nurita, can I ask more?
Okay.
I'm still don't get it. Why that when we add the thiamine, the propionate will decrease and acetate increase? Because only the glycolysis, or there is other reason also? Can you?
叔叔，你看到我的画面了吗？
夏博，你分享到你的画面了。
已经分享了，是不是？
对，你分享到你的荧幕。
好，可以。那我就，但是我自己看不见。
你现在要分享什么东西？
那个一个幻灯片。
那你要点出 PPT 啊。
你要点 PPT。
因为你现在是分享你整个荧幕，所以你直接对，然后你直接去下面点那个 PPT。
已经有了。
好，你讨厌下面那一条白色的，就按隐藏就好了。
可以看到了吗？
可以啊。
已经看到了是吧？
有。
OK， 好。刚才那sorry， whether Chad you already satisfied with Nurita's answer?
Yes, Professor. I said.
Could you explain again because I didn't hear?
Me or Nurita?
You.
You mean the question? My question, second question?
No. It's the answer. Question I know.
The answer was like when we add the thiamine, it undergoes the glycolysis, right? So it also increase the propionate and not propionate. It increase the lactate and acetic acid. So the control and the diet that with high concentrate with thiamine has low higher acetic acid and lactate, and for the only the concentrate one has the higher propionate, and for that enteritis it's usually because of LPS, right?
Okay. We have to be Nurita, we have to be very careful about this part. Why? Because Nurita, can you hear me?
Yes, Professor.
Okay. We have to be very careful about this part because the glycolysis to become the lactic acid and the pyruvic acid. Remember, also have pyruvic acid. Both of them are need not only one of thiamine. So I'm worried that if you only add thiamine, whether this can be get the lactic acid or pyruvic acid. Okay, so we have to be very careful about this part. Another thing is because pyruvic acid is direct go to the TCA cycle, so it's a very strong relation with propionic acid. Okay, and the lactic acid still need to go back to the pyruvic acid, then go to the TCA cycle, and then get the pyruvic propionic acid. So this part will have to be, if in the future people will ask you this question, you have to be very careful about this. Can you catch what I mean?
Yes, Professor.
Okay. Chad, can you understand my talk?
Yes.
Okay. The last things we need to talk today here Also, this most part of this slide is in picture. Okay, so don't worry about Chinese. Because today, have someone ask us this question in one of the big feed mill company, and this question is already for a long time, but I think still some people cannot understand why. That is DDGS and its color. Okay, because DDGS is not only for pigs, also for chicken, also for ruminant animal, and the DDGS is already take off most of the carbohydrate. So the DDGS usually is higher in fat, higher in amino acid, higher in protein, and higher in fiber. Okay, and also another very serious thing is higher in toxin, mycotoxin. So we have to understand, we have to understand this kind of 5 higher, and then we also need to understand whether the DDGS's digestibility will be higher or lower. And this research is did by one of the American professor. He said that you can actually see the DDGS digestibility from their color. Okay, so this is very, very interesting one, because usually we need to measure, but this one, they will think from the color, you can know their digestibility. You can know the DDGS have a different color here and produced from the different company. Why the DDGS have different color? It's because different company, they get the origin fermented corn, because they're using the fermented corn to produce ethanol, is alcohol. This kind of alcohol is using for the car purpose. Okay, so in this case, during the fermentation, if your fermentation is too long, and your color will be very dark, and if your DDGS is very dirty, you also will become very dark in color. So you can see they have different color. But interesting enough, you can see that DDGS have this color chart. Okay, one of the chart is 1, 2, 3, 4, 5. Okay, 1 is yellow, a little bit yellow, and 2 and 3 is became brown, and 5 is become dark brown. So we have to understand this kind of color. Okay, this color is the same thing as we mentioned just before about the yolks color, eggs yolks color. Okay, this kind of color you have to remember very clearly. 1 is yellow and 5 is brown. Okay, please remember this. And you can also compare from this color. This is a more realistic color. You can see the Y1, Y2 is usually a dark color, and UJB is a more light color. Okay, this is DDGS. So you can see they also have this kind of comparison card. Okay, this kind of card is same thing like yolk, eggs yolks card. Okay, and the most exciting one is this one. Okay, because here is the digestibility of lysine. Remember, here is digestibility of the lysine, and here is a color. And once the color is lower, there is a trend. They become brown. Okay, dark brown. And once the color is bright, is more yellow, they will become higher score. Here should say the color score is higher. So you can see here, is a L and B, and L and B is the same thing as we talking about the mid color. Okay, you can see if the lysine, if the color is dark, and the lysine's digestibility will be very low. Okay, if the color is bright or yellow, okay, or light brown, and you will see their digestibility will be very high. Okay, and people will say it's only lysine. No, cysteine is the same. Okay, this cysteine is the same. The color, if dark color, their digestibility is lower, and if the yellow or light brown, their digestibility will be higher. Okay, for the cysteine, and the last one is for the theorine. You can see the theorine is also the same trend. Okay, so its finding is really fantastic finding. I think maybe Ned is already read this before, but I hope all the students remember, if in the future you can finding this kind of relationship, you will become very famous. Okay, why? Because that is not only from the theoretical point of view, you are make things clearly, but also and very useful in the practical situation. Every time you see the DDGS in the dark brown, you know their digestibility is very low. Okay, it's no doubt about it. You don't need to measure their amino acid situation. Okay, digestibility. You can already 100% know this kind of thing. So this is a very important things. Okay, today I have someone mention about this color is very useful, but they didn't mention about this kind of digestibility. So I hope all my friends here, you can understand these kind of things more easily. 我现在要把它离开，我要回到我的。然后呢？
要不要看一下镜头哦？
好。OK。Why my handsome picture still not appear? Oh, okay. Yes. No. Okay. Any question about comments or question or suggestion about this? We mentioned before.
I have question.
Yes.
Because I'm wondering, because in monogastric animal, that when they are reduced pH, they will have a more lactic acid from microorganism that produce in the gut. But for ruminant animal, that Nurita mentioned that when we add vitamin B1, will have the effect to increase the pH, but they can still increase the lactic acid. Why?
Nurita, try to answer.
Thank you.
Excuse me. In my explanation, I mentioned I mentioned before, if in the rumen high produce of the lactic acid, it also will reduce the rumen pH. So I guess it's same happen between in the ruminant and the monogastric. Both of the high production of the lactate or lactic acid will reduce the pH.
But you mentioned that like thiamine, that they can increase pH in the rumen, right?
Yes.
Yeah, but for for monogastric point view that when the GI tract condition, they have a low pH, they can have more lactic acid.
Yes. I'm sorry, I didn't get the point.
No, I'm not sure I understand or not. Normally in ruminant condition, for the pH, they come from the microorganism in the rumen, right? And
Yes.
also vitamin B1, they also synthesis by microorganism. And when we add B1,
B2,
thiamine is B1 or B2?
B2.
B1.
B1. Sorry,
yeah.
sorry.
When we add B1 and then they increase the pH.
Oh yes, that's right.
Yeah. I'm not sure.
Increase, when you mean increase is reduce or
In my understanding, increase is getting higher.
yes. So became more alkaline.
Yes.
What I mean is for monogastric animal, we prefer low pH to produce lactic. But for your presentation, from your review, that mean thiamine will improve the microorganism condition by balance pH or increase pH.
Yes, because rumen's pH, especially in this rumen, for digesting the feed, especially fiber, because ruminant is herbivore, so it eat fibers, forage. So the pH should be more alkaline, not very low, because when the pH is high or the increasing of pH will improve the growth of the cellulotic bacteria. So because the cellulotic bacteria is very important for the ruminant. So if the
I think both. I think you didn't answer the question, because question is if we add the thiamine, the pH will increase. Okay, so the pH will increase, but in monogastric animal, we usually will prefer a little bit lower pH, so we will have lower diarrhea and lower some other condition. The question is why this kind of increase the when you add the thiamine, why increase the pH? And then in your situation, you prefer this one. I know your answer. Your answer said because ruminants usually they will have a neutral pH near the 7. Is different from the monogastric animal, because this is not in the abomasum. It's not in the true stomach. This is in the lumen, R-U-M-E-N, lumen itself. Am I right?
Yes.
Okay, so in this kind of situation, you prefer in the neutral situation rather than lower pH. Is that right?
Yes.
Yes. Okay. Now, the key point is why the thiamine add into the diets will increase the pH. Am I right? Mm-hmm.
Yes. I saw in the review that they also mentioned thiamine, they have the effect from other mechanism that they also can improve ruminant microorganism that they can produce more, like propionate or lactic acid or something like that. So maybe they can we just say they improve the balance for the microorganism?
What is your opinion, Nurita? Sorry, I have my own answer, but we better to ask you.
I think I need to find more because in my understanding, only with the addition of the thiamine, it will improve the growth of the cellulolytic bacteria because some of the cellulolytic bacteria is need thiamine for growth. So when the cellulolytic bacteria growth is high, and then it can maintain the rumen pH because not only cellulolytic bacteria but also, as I mentioned before, the Megaspiraeus genii is getting higher, and then it consume the lactate, so the pH is getting higher again. Even the bacteria is still produce produce the acid, but the pH is not getting very low as the lactate can make lower of the rumen pH. As I understand like that, Professor. Maybe I need to find more information.
Okay, can we explain like this way? Because if you add that thiamine, then they will reduce production of the lactic acid and pyruvic acid. Because the lactic acid and the pyruvic acid, they will transfer to the TCA cycle. So in this situation, their pH will increase. Although they still produce a little bit of propionic acid or some kind of acid, but that kind of acid is not as acid as pyruvic acid or lactic acid. Can you catch what I mean?
Yes.
Okay, so this is maybe another possibility. Okay, because the same thing happens in the human being. If you add a vitamin B complex, you always will reduce your muscles sour. Okay. And once you reduce your muscles sour, that means you reduce your lactic acid accumulation. And then it reduce the pH drop down, and then they increase the pH. Okay. That is happen in my body all the time. So why we explain like this way. Any other comments or suggestion? If not, then we will close today's seminar. In the old time, we always have two person to give a presentation, but now it's because the member is not so big. So if two person give a presentation, and then the turnover rate is too high, and once the turnover rate is too high, and then the people's burden will be very high. So at the moment we will give one, and I always will give a short one. Okay, I try to give a short one to let us have some kind of discussion. Any comments or suggestion or question about Nurita's and my small presentation? Okay, if not, and then I will say goodbye to everyone. Good night to everyone. Good night.
Good night, Dr. Hsia.
Good night.
Good night,
See
everyone.
See you next week. See you
Good
next
night.
week. And the Thai student, see you next week. The other student, you have to go. You have to come. So I of course will see you. Chen Xin, where you go next week?
Maybe just waiting the flight because the person is too low, so maybe the flight will cancel.
Okay. Maybe the flight is waiting for me. Okay. See you. Bye bye, everyone.
Good night. Bye bye.
Good night.
Good night.
Good night.